Hi and welcome to another Hopper on microcontrollers video. Hopper is a modern semicolon and curly braces language, a little bit like Java or C#. In other words, it has garbage collection, and it has a full symbolic debugger from the Windows desktop, even when you're running on the microcontroller. For the purposes of just MicroPython is relatively popular on these microcontrollers. So for the purpose of helping people who are familiar with MicroPython understand what Hopper is about, that's why I'm making these videos. This is a bit of a benchmark to show performance side by side. None of these benchmarks are particularly good, but this was kind of the best one I could find. I'm not much of a Python guy, so I found this Fibonacci sequence benchmark online. I can include the link. It's quite old. It's 2021. It's not that old, but it was an easy one to show side by side. Yeah, I'll include the link in the comments below so you can see which one I used. So that's the Python version here in Thonny, and the Hopper version here in the Hopper IDE on Windows. So Hopper is a compiled language, so F7, I'll compile it. Thonny is interpreted, so I just have to run it. So I'm doing 10 iterations here of this benchmark, and then it'll divide the time by the number of iterations, and we'll get the average time per loop, and it's calculating Fibonacci to 24. Let's try this. Should take about 20 seconds. Let's get this loaded up. So while the other one's going, since I have two devices running, so successfully uploaded the Fibonacci to the microcontroller, and now I can run it. So there we go. It's 1.8 seconds per iteration in MicroPython, which is pretty much exactly what the guy who posted that benchmark had in 2021, so two years ago. So let's see if I run it. I can run without the debugger here or with the debugger. If I run without the debugger, it'll be faster because it won't be looking for breakpoints. So that seems fair since there isn't a debugger here in the Thonny interface. So Control F5 to run without a debugger. Again, this should take about 20 seconds. The code is pretty much identical. This benchmark is constrained by, it's basically very heavily dependent on function calls, some addition and subtraction, and yes, an if statement, a branch, but mainly function calls. And the time it's come back has the serial console output on the top right, so 1.8 seconds effectively, 1.85. So close enough. I mean, they're pretty comparable. And this is about as tight an inner loop you're going to get. And then that number there is how many times the function was called, really. So it's a lot of laps multiplied by 10, testing how fast function calls are, addition, subtraction, and conditional branches, which tests a lot, actually. I mean, it'd be nice if it has sort of a loop test in it, but it doesn't. So relatively comparable. But the difference with the Hopper environment is I can press F9, set some breakpoints, and then I can rerun. I can start again here with debugging, and if I press F5, now I can step through this in the debugger. And as I step in, we can see the recursion in the call stack on the right here as it steps down, and we can see the local variables, in this case the arguments, etc. And it'll be a lot slower in the debugger when it's running the debugger because it's got to check for breakpoints on every run. Anyway, like I said, I don't see this as a particularly good benchmark. And yeah, full disclosure, Python is using 32-bit integers here. If Hopper's had 32-bit integers as its uint in the architecture, it would probably be a similar speed. That's not actually the speed constraint, but Hopper is essentially, it's got 16-bit stack elements, and the reason is so that it can be very efficient on 8-bit CPUs like the Z80 and the 6502. So I'm using uints here, which are 16 bits. And it's fine because the total never goes over the 16-bit limit. But, you know, if I used longs here, in Hopper, long is a reference type, so that'd be the same as like a string type in Python. So it would be a lot slower if I was using a reference type. On Windows, the Hopper type for uint is actually 32 bits wide, and it could be 32 bits wide on the Pico as well. But I just have chosen not to do that so that I've got the same runtime on all platforms. Another thing we can look at is what this looks like in Hopper. So as part of my build process, I said run the disassembler. So if I go out to the console and then I say show, and the output will be in the debug folder, Fibonacci uint has them. Oh, I should say more because it just ran through all of it. And then what we can see here at this, where this enter is and where this return statement is. Between here, this is that inner loop of this benchmark. So the if statement, return the one or return the other with the additions in it. So this is what we're benchmarking. These are the virtual machine opcodes inside Hopper. And it is interesting that they both roughly 1.8 seconds for this benchmark, which sounds very promising from my perspective for Hopper, because I've only had this runtime running on the Raspberry Pi Pico for about 2 months. Whereas this runtime of the MicroPython runtime has existed for 10 years. So they managed to get it to 1.8 seconds in 10 years. And by they, I mean, yes, there's more than one person working on this, whereas for this, it's just me. And I reckon I've been at this for 2 years, but I've only been working on the runtime for the microcontrollers for about 2 months. Anyway, I'll end on this for closing screen. I'm by no means a Python or MicroPython expert, so if you think if you think I've been unfair to Thonny or MicroPython, please inform me in the comments and I'll make corrections. Thank you for watching, and I look forward to your feedback.